Okay, in this video we're going to solve a basic trigonometric equation. Now, if you watch the background video, when you see solve, that means we're going to have infinite number of solutions. And if that doesn't make any sense to you, you need to go watch the background video number 2. We're going to have an infinite number of solutions, and we're going to answer in radians. So our first step is, just like we would do for 2x minus 1 equals 0, we would get the x by itself. We're going to get sine of x by itself. So I'm going to start by adding 1 to both sides. 2 sine of x is equal to 1. And then I'm going to solve for sine of x by dividing by 2. The sine of x is positive 1/2. Now, when I do this, that means I have two answers because there are two quadrants that will give me a sine value that is positive. Those quadrants are, according to all students take classes, those are the first and second quadrants, all in students. I know that this triangle has an opposite of 1 and a hypotenuse of 2. And I know then, therefore, if I want to, I can use arc sine of 1/2. And that'll tell me what that angle is. That'll tell me that the angle is, if I'm in degrees, it'll tell me that it's 30 degrees. So you want to make sure your calculator's in the right mode there. That'll make that much more interpretable. Otherwise, you're going to get a decimal answer that's probably not going to make sense to you. So, if this angle is 30 degrees and I have two answers, that means that this one here is 30 degrees for an overall angle, right? And this is an overall angle of 150 degrees, just like in the last example problem. All right. Now, the problem is that this 30 degrees repeats itself every 360, right? I could say 390 degrees. I could say 750 degrees. That's 2 rotations plus another 30. In other words, it repeats itself every 360 degrees, or 2 pi if we're talking in radians. So I'm going to do two things here. I'm going to have two answers. The first is going to be 30 degrees given in radians. That's pi over 6. That's 30 degrees in radians. My second answer is going to be 150 degrees given in radians. So 30 times 5 gives me 150. That means I need to take this and multiply it times 5 for the answer for 150 in radians. And then each of those is going to repeat themselves every multiple of 2 pi thereafter. And I have my answer. Let's take a look at the one on the right. Same problem, except this time it's cosine, right? So I would solve this and I would work through everything, and it would turn out that cosine of x is equal to 1/2, just like we got sine of x is equal to 1/2. So I'm looking for quadrants in which the cosine is a positive value. And according to that, that's going to be the first quadrant and the fourth quadrant. That's all students take classes. It tells me that. All right, now this time the adjacent is 1 and the hypotenuse is 2. That means that the third side is the square root of 3. This is the 30, 60, 90 degree triangle with the interior angle I'm interested in being a 60 degree angle. That's 60 degrees on the inside. Of course, if I wasn't for sure, I could always do x is the arc cosine of 1/2. And that would tell me, if my calculator was in degrees, that it was 60 degrees. So I know that I'm working with 60 degree angles. You just then have to make the adjustment for the quadrants. Okay, now that being said then, that means I have really two angles to work with here. The first one's just a plain 60 degrees, but the second one is really this angle here, which is 360 minus 60. That's 300 degrees. So let's take that, and I notice that they both repeat themselves every 360 degrees, right? It's going to repeat itself. That's every 2 pi. So my answer is going to be 60 degrees, which is pi over 3, plus multiples of 2 pi. And my second answer is going to be 300 degrees, which is, let's see, 6 times 5 gives me 30. So 60 times 5 gives me 300. That's going to be 5 pi over 3 sections. And multiples of 2 pi afterward. Here's my answer. And that's how to solve a basic trigonometric equation with only like a sine function or one cosine function and nothing squared. You can see in the next video what we're going to be doing is the same kind of idea, but now we're going to be dealing with squares.